Hello again. Since the last video got cut off, I ran out of storage on my phone. I'm going to do this again. So here we are talking about chemical bonding. The first one talks about ionic bonds. In an ionic bond, electrons are transferred from a metal that wants to give up electrons to a non-metal that wants to gain electrons. In doing so, they both become ions, so they both become charged particles, and charged particles will attract each other. So that's how an ionic compound forms. To show that, what we do is we draw the electron dot structure for each. So lithium has 1 valence electron, chlorine has 7. Okay, this is a great relationship because lithium wants to get rid of its 1, which it will do in the next step. Chlorine will gain that. In doing so, lithium lost 1 electron, so it becomes positive 1 charge. And chlorine gained 1 electron. Electrons are negative, so it becomes a negative 1 charge. Okay, to show the formula, you leave the charges, and if there's numbers down below in the next example you'll see, you put them in. So in the next example is for magnesium and fluorine. Magnesium has 2 valence electrons, fluorine has 7. Okay, so magnesium's going to give up 1 electron to fluorine. Fluorine's going to be happy because it's got a full outer ring. It can't take 2 because it only wants 1. So magnesium's going to have to find another fluorine to give its other electron to. Okay, so it will do that. Magnesium lost 2 electrons. There's only 1 of them. Okay, so it becomes a +2 charge. Fluorine gained 1 electron each, and there's 2 of them. Okay, so these are the charges up top. The number down below represents how many it took. So to do the chemical formula, drop the charges up top, keep the bottoms, and you get MgF2. Okay? Sometimes you'll have, you need multiple metals to react with only 1 non-metal. Okay? Sometimes you'll need a couple of metals to react with a couple of non-metals. You just keep working it until everybody's happy. Let's go on to covalent bonds. Okay? In a covalent bond, they're both non-metals. Okay? So they both have more than 5 valence electrons, 5 or more. Okay? They want to gain electrons. Neither one of these wants to give up electrons. So what they do is they share a pair of electrons instead of transfer. They're not completely happy doing so because they'd rather have an electron or give up an electron, but in this case, they're just going to share. Okay? So what happens here is we have sulfur and chlorine. Okay? Here, sulfur has 6 valence, so it needs to share 2. Chlorine only needs to share 1. So what you're going to have in the next is 1 electron from sulfur shares with 1 electron from chlorine. This chlorine's happy, it's not going to share anymore. Sulfur needs to find another chlorine in order to share the other electron with. So it does that. This circle represents a shared pair of electrons. And then you just bring the 2 together. There are no charges. There are no step 3 like we had in the ionic bonds because these particles do not form ions. So I'll do one more example here where we have P and F. Okay? So P has 5 valence electrons. F has 7. So P wants to make bonds with 3 Fs. So it makes bonds with 3 Fs. Okay? Shared pair. P has 8 electrons, 2, 2, 2, 2. Fluorines all have 8 electrons. Everybody's happy. So you get the formula PF3. I hope this helps. Send me messages if you need further explanation. Thank you.